Hi, and welcome to this Feature Fridays. My name is Guy Bartram, I'm the Director of Product Marketing for our cloud providers at Broadcom, and I'm joined today by Sachi. Sachi, welcome back. Why don't you just introduce people and tell people what you do?
Yeah, sure. Hi, Guy, and hi, everyone. I am Sachi. I am technical product management. I'm part of the technical product management team, and I focus on container solutions for our cloud service providers, um, and part of the Broadcom team now.
Yeah, so everything under kind of the modern apps with our new portfolio of Cloud Foundation focused solutions. That's where you're playing, right?
Yes, that is exactly right.
Cool, cool. And we're here today to discuss something that our service providers have been asking for a long time, which is OpenShift, right? I mean, it's not a VMware product; it's a Red Hat product, but lots of providers use this today to deliver solutions to their customers, and it's been a big ask from our service provider community to get it, included and working into our VCF platform. So we're going to go run through that today, right?
Yes, that is correct. And I have a few slides and a short demo to
Okay.
talk about what is OpenShift on VMware Cloud Foundation, why we need it, and how it works. And
Yeah, perfect.
we also have a cool demo where you can actually add a GPU worker node on top of OpenShift cluster. So if cloud providers are looking for supporting or offering modern or AI workloads, uh, we have a solution not only on VCF but also with OpenShift. So let's get
Perfect.
started.
Yeah,
Yeah.
go for it.
So we'll just review why we really need VCF with OpenShift. The main reason is that um, uh, the power of VCF uh, along with OpenShift, right? So we know why we chose VMware Cloud Foundation model. It allows our CSPs to actually simplify their deployment and carve out the capacity, give the whole infrastructure suit to the customer, and then they can replicate it for multiple customers. So it's
Yep.
more like simplify and then multiply the deployment. And with OpenShift, they can use that, leverage that VCF model, and then customers can leverage OpenShift on top of VCF. Now, we think that OpenShift on bare metal works perfectly fine. Why we need specifically with VCF or vCenter? So, number one, if you are deploying OpenShift on bare metal, you most of the time chances are customers are over provisioning their infrastructure and spending a lot of cost in running the heavy clusters in anticipation that the traffic will be high.
Yeah.
With VCF, we get that ability to start small and then scale as and when we need it, scale down as and when we need it. So it reduces lot of operational cost and also infrastructure cost for running those clusters. And with VCF, the lifecycle management of other components, supporting components, or to run that OpenShift also becomes very easy. So those are the main two whys we would like to for our CSPs to consider that it actually is a very viable solution. Okay.
Yeah, you raise a really good point there, and I think it's worth emphasizing. A lot of service providers, have deployed Cloud Foundation successfully and seen really good results with the ability to deploy kind of custom. I call them pods, customer pods, customer workload domains, and
Yes.
simply add and remove like resources at a host level. Just add another host, bring that host into the customer workload domain, and have it up and running within sort of 15 minutes as a resource to the customer to use. And I think that enables, as you say, like with the automation of the SDC manager and the components that it manages from Cloud Foundation, it gives a really good, highly repeatable, highly automatable kind of solution for delivering additional solutions like this on top.
Yep. And we recently we came up and we proposed a few deployment models for our cloud service providers. And today's focus is mainly on the hosted private cloud, where cloud service provider is going to provide workload domains, dedicated workload domain per customer organization, right? So here, the idea is that each customer will have their own management domain, which cloud service provider will manage, and workload domain will be managed by the customer themselves. So the value add here is that customer who is really used to working with VMware infrastructure stack, they can actually adopt this deployment model where they can manage their own infrastructure and services on top of that infrastructure in that workload domain. And as and when they require additional resources, they can request it to service provider and scale the existing workload domain, or for different use case, they can create a new workload domain. So this diagram is depicting exactly what I just described. Yeah. So, and then we are talking about, provider can manage many different services, and we are focusing on app modernization. Now, we already know we have, in app modernization, we have an extensive portfolio of Tanzu products, but we have seen the demand for OpenShift, and we want to recognize that and offer it to our CSPs. Yeah. So let's go into little details of like how this is going to work. So like we mentioned, we are using VMware Cloud Foundation. So main products we are going to use there are vSphere, vSphere Stack, ESXi, vCenter, SDDC Manager, things like that. For storage, we have vSAN, and for networking, we use NSX. NSX provides two different capabilities here. One is the routing and the networks, and also it also works with Entria to provide the CNI interface on top of the cluster we create. So the reason we chose Entria is that like despite of having OpenShift their own CNI or cloud network interface, we realized that with NSX we can harness a lot more features of NSX and Entria together. So that's the choice of the network interface we are going to use here. Okay. And for the GPU workloads, it's not a mandatory requirement. The solution supports NVIDIA GPU cards, but it's not a mandatory requirement. Even without GPU, we can still have OpenShift container platform and clusters on top of that.
Yeah, that's a really nice additional offering though for providers looking to do something different for their customers and looking for high performance compute environments as well.
Yes, and we have to recognize that with additional and more demanding generative AI workloads, and we know that all the workloads in production, all the LLMs and all the generative AI workloads, they are all running on Kubernetes today. So it is like no brainer for providers to actually start adopting this in GPU service, right? And vSphere, we have a way to harness the power of GPU and then break it into vGPUs and then slice it and utilize the resources more efficiently with vSphere. So we are harnessing that and then also working with OpenShift on top of that.
Yeah. So really providing that underlying infrastructure that OpenShift is going to kind of exist on top of, with some flexibility to use like NVIDIA GPU, slice it up into vGPU, as you said. That's a vSphere function, and also then using like things like the Treya networking and things. So yeah, cool.
Okay. Yeah. And in that, like NVIDIA, what we do is actually we have the existing ESXi infrastructure, and then we insert the additional hardware. So We do the similar thing when we incorporate GPU workloads on top of OpenShift. So we actually add additional hardware on your cluster and then recognize that as a GPU node.
Yeah.
We'll see that in the demo. Okay. So now comes the like one level down detail on like how provider is going to manage the management domain, offer or deliver the workload domain to the customer. And then over here, we'll deploy the OpenShift cluster on the workload domain. And over here, we can, if the GPU card is inserted already on those ESXi hosts, we can actually allocate specific vGPU resources to each worker node to make it a GPU cluster.
Yeah.
Okay. Here, this is like for this design, this is what we have used so far. We have used the PowerEdge Dell servers. We have a good amount of memory for the network and so storage adapter. We have the VMware's native adapter, so we don't need a specific adapter for that. And for GPU, we are using A100 card as part of the demo here.
This is just the demo setup, right? This is not saying
Yes,
you need
it's
this
not.
to do this. Yeah.
No. It's
Yeah.
just something we have used this to deliver the content.
Yeah, sure.
Okay, and this is the bill of material. If we have to run the stack, we have taken the latest and greatest VCF 5.1, OpenShift 4.13. That's the latest OpenShift release. NSX 4.1, vSphere 8.0 U2, and Entry is also the latest plugin for OpenShift. Right. So the idea is that we have a support on this. We have been, the team has been verifying this release over release for the older VCF versions as well. And this is now supported on 5.1. Okay. So now comes, so now we understood why we needed what we are doing. Now we are going into the details, like how we are going to install this and leverage OpenShift on VCF. So first of all, if you have existing VCF stack, that's good. Otherwise, we need that. Second one is we need to prepare the workload domain. As part of the preparation, we have to ensure that all the resources are in place, vGPU, PCI cards are installed, and we can recognize those vGPUs on the ESXi server. As part of the network configuration, we do three things. One is the DHCP. Second is DNS. Kubernetes is like in general essential for DNS is essential. DHCP and DNS. And the third one is static IP addresses, which is required for our OpenShift clusters to run the installer also and the cluster itself. And
is that for the cluster kind of the cluster's IP or
yeah,
management IP?
It's basically the API interface for the cluster.
Yeah. Okay.
Yeah, right. The management.
Yeah.
Okay. Then so once the cluster is up and running, we have to change the networking interface replacement with Entria. Then we have to integrate it with NSX, and then last one is the installing the operator. Now I want to highlight here is that we are having two additional licenses, right? One is for the OpenShift itself, and second one is for the AI operator from NVIDIA. So to get the CUDA, get the operator up and running, we need additional NVIDIA licenses, right? Okay.
And you can still, so those operators, are they automatically deployed, or they require manual deployment?
So OpenShift comes with an extensive list of operators. NVIDIA has published their own operator to work with specific version of the hardware anyway. So OpenShift UI actually provides us that nice click button
to deploy the operators.
Yes.
Okay.
Customer can go and click on the operator, and then it will be installed on top of the cluster.
I think the NVIDIA one in this case would be a manual deployment, because it's not like before when we were deploying it via App Launchpad or the marketplace or something. So we could automate with Tanzu, the NVIDIA operator. That's
Yes.
no longer the case here, right? Because you're not using Tanzu. So this is something that you'd have to look at.
Yeah. I mean, which is correct. Yeah.
Okay, that's cool. Just good to know.
Yeah. And all right. So in my demo environment, I already have created a cluster. So essentially, what we need from a solution point of view to get started, after we have prepared our infrastructure, we actually install the API interface, connect it with our the existing data center, and the snapshot exactly describes that. Once it is connected, you can actually see what are the network information what you have connected. And once the cluster is up and running, you can actually see all the nodes using the OpenShift, its own CLI, just like kubectl. And you can see here, we have taken the snapshot of the control plane and the worker plane nodes. And once the cluster is up and running, you can actually go to the OpenShift's UI, which comes out of the box after the cluster is deployed. And then over here, you can actually deploy any number of operators you want. So in this case, since we are talking about GPU, we will deploy the NVIDIA operator like this.
Oh, okay, got it.
Okay.
Oh, that's great. So you can do that. Okay, so that means it's automated in point and click.
Yes. Yes. Okay. With that, I will shift to the demo, and then we'll talk about design considerations or things we need to pay attention to when we are using the solution.
Okay.
So in this demo, what we will see is we have created a OpenShift cluster already on top of our VCF, and here we are logged into vCenter server, and in our workload domain, we have a cluster called C1-Entria. So that cluster has 3 master nodes and 4 worker nodes. And the goal of this demo is to show that how to attach the GPU, vGPU to the worker node, and then install the operator, and then demo concludes with an app which runs on top of this cluster using the vGPU. So yeah, the demo is about vector addition. So vector addition is supposed to be very comprehensive, very compute intensive operation. And without vGPU, it takes very long time. So we'll see how it used the CUDA and how the this process completed very fast. So let's get started. So here you can see we are picking one worker node, and in that worker node, we are actually going to add additional PCI driver to recognize the vGPU. So we go to the edit settings, and then in the PCI device, we already have the vGPU grid. So we are going to add a new one. And then we can pick whatever vGPU is available for us, or based on the requirements. And then once that is done, we actually go to the NSX to see how it is actually going to that specific vGPU. So in this example, I'll just pause here and describe. So OpenShift uses a single tier 1 gateway. So customer can deploy multiple OCP clusters just like any VM workloads with the same tier 1 gateway or same tier 1 router for their specific network topology, right? So in this case, you can see each cluster will have its own segment, and then on top of that, we have multiple VMs, which are nothing but the cluster nodes.
Yeah.
Okay. And then over here, you can actually see what is the node, and after that,
gateways. Yeah.
yeah, and then it actually shows which tier 0 and tier 1 gateway are connected and which nodes are connected to that. And then now we log into the cluster itself to install the NVIDIA operator. So this is the UI, the OpenShift cluster management UI, where you can see all the cluster nodes and then install the operators on top of that. So you go here, they actually show what is installed. So Entria manual installation was completed. And here on nodes, you can actually see on which worker node we have the NVIDIA operator configured, right? So you can actually see over here, we have a few CUDA NVIDIA labels are there, and then pods will be running there.
Yeah, GPU deploy operators. Yeah.
Yeah. And then we'll conclude. So it actually shows the which host driver versions are already present, right?
Yeah.
And then now we'll conclude with the part where we install the run a demo app.
Mm-hmm.
So this is nothing but a jump host where it can connect to the OpenShift clusters on the same network. And over here, now we are going to point to our kubeconfig where our OCP cluster is running. And then, yeah, one thing is here, we don't use directly kubectl. They actually use the OpenShift specific CLI over here. Okay. And then this is where you have Entria, and like it's actually basically showing all the components we have installed on top of it. And then this is the vector add application configuration, where we show the image, which image it's going to use, and then which application it's running, right, as part of that. And then once it's configured, it actually completed the test where we the CUDA kernel launched, and then it ran parallel 256 threads to add 50,000 vectors. And then the operation actually completed very quickly, and then the test passed. So basically, it shows that we actually consume the GPU that we connected to our worker node.
So there's only a couple of, the NSX work you were doing there was literally just checking the connectivity. It's really making sure the operators are deployed, and obviously OpenShift is configured correctly, and then looking at your deployment YAML files of what you want to deploy.
Mm-hmm. Yeah, one just quick thing on that. We also have to change the network interface from the default one on the OCP cluster to the Entria. So that is one extra step. Yeah.
Very cool.
Okay. And yeah, everything is described in the reference design. We can post the link along with the video. So that reference architecture paper actually goes into each and every detail of if our CSPs want to take advantage of that, they can actually plan the capacity and look through all the installation steps and plan their service offering based off of that. So yeah, they can take advantage of that.
So it's actually, I mean, looking at this now, what's the actual support and work that's been done? Is it more kind of validation work that's been done? Because I'm trying to see where the automation's been kind of coded for us, or if there has been any, because it seems like a lot of the default functionality has been used.
Yes. So this work is mainly validation, that it works with our VCF stack. I
Okay.
don't think we have any automation in place. It is still pretty much manual stuff that you have to use the IPI installer, create the cluster, and then change the components and then make it work with GPU.
Yeah. Yeah.
So
Okay.
I don't think we have any automation work in place for that as of
Yeah.
now.
Cool. Yeah.
Yeah,
That's why I figured it looked like it was just using you know, the existing functionality basically, and just so
that is
it's
correct.
verified by us and supported now.
Yes,
That's supported
yes,
configuration. Okay. Great.
yeah.
Fantastic. Sachi, brilliant. Thank you very much for showing us, you know, around the solution and giving us a quick demo. I really appreciate it.
Okay, thank you very much, guys.